Hi, good morning everyone. So today I'm going to show you four pieces of the teaching apparatus. So I hope you can just, you may find use. Hi. Please take panels there. Okay. And the four pieces of apparatus is, the first one is the turntable. It can stimulate the rotate of Earth. And the water inside the tank here can simulate like the atmospheric circulation. And the second one is this renewable energy education kit. It can, it has wind energy and also has a solar panel here. And I will show you, just use the solar energy because we are inside. So I'm gonna use a battery instead of the solar panel and the wind energy, and I will show you the transformation of water into hydrogen and oxygen, and using that hydrogen to work with this is a fuel cell to transfer the hydrogen into electricity and to start a motor. Okay, and the third piece is this one, thermodynamics. It's a gas, ideal gas expansion apparatus. It has two experiments so far, but I think you can just make experiments by yourself. So I will. The last one is this flume, and it's a fluid dynamics. It has a lot of exercise. So I will show you the using of this one with the first one with Christware shot. Christware shot put here. So first of all, I will show you the usage of this this tank. So we have a motor here which can control the rotation speed of this tank. This tank is already filled with water. So because we need about 10 minutes to put this can in, and we need to wait 10 minutes for them to become a full body movement, a solid body movement. And you can control the rotation speed by just turn on this switch. And also there's a screen here because there's a camera there, and it can show you what happens inside from above, from the viewpoint of above. And let's see.
It's a smart TV. It takes forever to boot up.
Let me choose the HDMI one. Okay. Yeah. And now I just print a map of using the North Pole as the center. And there's a lamp here. You can see. Yep, I just printed and I just flip it because if you don't, those colors will just mix with your dye together. And the first step, I will put a can there like the North Pole, and I will pour ice inside.
clear on the video, but there's a weight inside that,
Yeah, there's a
inside
weight.
that can that's holding the can down. So
Yeah,
it
it's a little
doesn't
difficult.
float away before it gets filled.
Now pour water. So as doing this, we'll simulate like it's the ice in the Arctic area, and the water is room temperature. And next step, we are going to drop dice using dice of different colors.
We have a baroclinic fluid now in
Yeah.
that tank.
Yeah.
Temperature gradients.
And baroclinic fluid inside there, and we will use the dye to just let you see the circulation.
Is that gradient established almost immediately, or does it take a little time?
It's pretty quick.
Yeah,
Thank
just a few minutes. I think 1 or 2
Pouring
minutes.
the water into the can with the ice really helps make good thermal contact. And that
Yeah,
really speeds up the chilling of the water inside the tank.
Yep. So there should be like a cold fluid at the peripheral of the can, and the warm fluid at the peripheral, like the equator. And I will drop blue dyes here at the Arctic area.
Experience with these tanks suggests that just tiny drops of dye is all you need. If you put big globs, then it becomes actually harder to see what's going on. A little dropped here and there.
Yep, and the right dye as the warm water at the equator area.
Do you need to set it up with a specific rotation rate to make this work well?
No, if you only need to let the rotation speed higher than 10 RPM, it should be okay. Now I just set it at 40. Any speed, higher than 10 is okay.
It depends what you're trying to do. So what we can see now is really clear evidence of these baroclinic eddies that have been created just because of that temperature gradient. So there's literally baroclinic instability at work in this tank. It turns out, and there's a whole online guide for these experiments, but if you do basically the same procedure but at a very low rotation rate, and if you're really careful, you can visualize a flow that doesn't have these instabilities in them. And then you just see a very clear evidence of a thermal wind relationship, because you see very clearly that the water is moving azimuthally more quickly near the top than at the bottom. So there's a vertical wind shear. It's harder to see here because of the presence of all of these eddies. That is, you don't get the nice radial symmetry that you would get without the eddies. But this is kind of the more beautiful demonstration. It just spins up these nice analogs of synoptic cyclones in the tank just because of the rotation and the temperature gradient.
How would you visualize the thermal wind? By looking in the side of the tank and you would see the dye getting sheared out?
Essentially, yes. We have another.
Yeah, you can use these paramagnates, just the crystals.
Yeah.
Yeah, you drop it into there, and you can see the vertical
Right,
movements.
so those.
And also at the bottom, the curve at the bottom.
Those crystals will drop directly to the bottom as soon as you drop them in the water, and they'll leave a dye streak just vertically in the column, and so then it becomes immediately clear if there's any shear, that streak is gonna get tilted right away. So if you drop it in, if we don't have the ice bucket in there, we don't have temperature gradients, and we don't tend to see that thermal wind relationship, there's no geostrophic shear in that case. So there's a lot of different things you can visualize.
So what we're seeing here on the screen, is that mostly representation of the surface? Or is it translucent and we see sort of an integral through the...
That's a great question, Professor Louis. Why don't you go up and look carefully at the cross section? And tell us what you
Yeah.
see if you look in cross section across the tank versus.
Yeah, it's not just the surface what we're looking at, obviously, it's mostly deep.
So, yeah, so we do, if you look.
It's nice to see it here though, because you do get a different impression from just looking at the screen.
That's right.
Yeah.
So when I've used these tanks in class, I usually invite students up to do what Matthias is doing right now, which is to look carefully at both the inertial frame of the classroom and the rotating frame in the camera.
Yeah.
But one of the things we see is that evidence of what we like to call vertical rigidity of the flow, where there's streaks of dye that you can see in cross-section are basically just the dye is sort of neutrally buoyant in the water, and it's just sort of moving along in its complicated horizontal path, but as a largely coherent in the vertical. So we like to point out how different that is from the turbulence you get in a non-rotating fluid. If we take a tank of water that isn't on the turntable and just agitate it and put dye in, there is no vertical structure in that flow. It's just a three-dimensional mess. And that is not what you see here.
So now I can just turn on the lamp, and you can just, because it's a simulation of the Earth system, and you can see at the middle latitude, there are a lot of the baroclinic eddies here. So it's I just get this idea from the YouTube videos. Yeah, I just print a map there. So
I think that's kind of magical. How's that actually working? There's a piece of paper underneath the tank that you're projecting through, and it doesn't show up when the lamp's not on?
Yeah, I think
There's
here.
a big, it's a big light square underneath, so it's lighting up the whole base.
Yep.
So
here you can see the different area, middle latitude.
Why does it look white before you turn the light on?
there's
There's
white,
No light.
Is there like a thin layer?
there's a white plastic sheet at the bottom.
Okay.
And
So it's
then,
underneath that plastic sheet, the paper?
I don't know, where exactly is the paper?
Yeah, just under
It's between
this
between the light
this
table and the
tank.
tank?
Yeah.
I'm just surprised that I didn't see it that you don't see the map when you just have clear water in there. Like why it disappears when you turn the light off.
It's just not enough light, I guess.
not.
It's cool.
No, that's really neat. I hadn't seen that part before.
Okay, so your students can just see directly like the atmospheric circulation and on the north hemisphere, right? So that's our first demonstration.
Well, quick practical question. You can just dispose of the water and the dye in the sink.
Yeah, it's just water with food coloring in it. So what you don't do is try to pick it up because the tank is not strong enough and it's very heavy.
Yeah, there's a pump there. Pump.
Yeah. So maybe for the sake of this video,
Yeah.
it's never been unpackaged on this one. But each one of these units, and we have several of these carts in the storage room, each one has a little pump that plugs into a little DC power supply on the cart. And you can just wheel it over to the sink and you can pump directly into the sink until it's mostly empty and then you can pick it up and rinse it out. Yep. There's a floor drain in this room. Actually, he is standing right on it. And for some things, that's the best option, but for these small tanks, wheeling it over to the sink is the way to go.
So I know, so we got these several of these tanks, right?
4 or 5?
Yeah,
So we have 4 new ones and the old one, which is very similar.
so presumably the idea with that was that it could be a class activity, not just a demonstration. Has that been implemented in any specific class yet, or
Not
is
yet.
there plans? Is there thoughts?
That's why we're trying to teach more people how
Are
to
there
use
thoughts as
them.
to which class that would fit?
That's
Yeah,
a
you can
great
also-
question for an undergraduate program director.
Well, I don't think I think I don't teach the classes, any of the classes that this. I mean, I guess I don't know. But you've done a lot. You've taught dynamics and you've done a lot with this. Do you have thoughts on what class would fit the best in?
I'm going to pause the video because this is a great question,
Kinda
but
side
not
note.
one we
Yeah,
need
yeah,
to
sure.
memorialize.